Good morning, ladies and gentlemen. My name is Rahmat Widya Wicaksana Putra. I am from Microelectronics Center, Institut Teknologi Bandung, Indonesia. I would like to say sorry because I cannot attend the conference event because of my injuries that I got from sports. That's why I'd like to thanks to the ICEIC committee, which has given me this opportunity to present my paper in a video recording. Okay, let's get started. My paper, which is presented here, entitled Hybrid Multi-System on Chip Architecture, a Rapid Development Design for High Flexibility System. Backgrounds why I chose this topic for my research, because as we know, SoC technology has forced many development in electronics fields, especially on embedded system. And since its technology has been used in many electronic devices in our life, so I think we can say that SoC technology is indispensable in our daily life. Because of these conditions, many demands from the customers try to make the SoC technology evolve more and more. The demands can be broken down into several points, as we know. For example, small area, high speed, low power, reliable, good configurability, and short development time. So, in order to fulfill these demands, let's try to revisit the standard SoC architecture. We can see that the standard SoC architecture is actually built from several resources, IP cores, which are integrated together into a single system by using plug-and-play design. And because of this approach, development time of the system is relatively short. But we have concerns about this design, because by the time, increasing number of components in SoC can affect significantly for area occupation, performance speed, and energy consumption. That's why the negative side of standard SoC architecture is actually because of this today's technology scaling cannot keep up with the design complexity. This condition can affect to high energy consumption, unpredicted delays, and synchronization errors. That's why many researchers try to overcome this condition by designing NOC architecture, network on chip architecture. We can see that NOC architecture is built from several resources which are integrated together in a grid-like architecture and router-like mechanism. Because of this approach, the on-chip connection is very efficient and it allows multi-path data transfer. That's why it's very promising technology for future development. But for today's development, the design is very complex. That's why it cannot be easily designed and developed. And it may cause the development time to be longer than standard SoC. That's why, because of this condition, I like to propose an alternative design of SoC architecture. That's why my research target is propose a design methodology and a prototype of SoC architecture with such characteristics in order to be an alternative and answer several demands from the customers. For example, efficient on-chip connectivity, easy development and implementation, good flexibility and configurability for physical and application development, and short development time. Those 4 points are our target. In order to achieve those targets, I'd like to introduce the hybrid multi-system on-chip architecture, which we call H-MSoC for a nickname. The idea is to separate physical SoC and application SoC. Physical SoC means that the SoC will be developed for physical development purpose. For example, IP cores development, uh, mathematical computation, or another kind of hardware development. An application SoC is supposed to be a platform for application development. That's why we don't need to do many modification in hardware for application SoC. For each SoC, there are similar layers involved. For example, dedicated SoC hardware, operating system, application, and data. But for each SoC, dedicated SoC could be different and could be vary. And for the operating system itself could be different, because I think physical SoC doesn't need any advanced OS, and it only needs light OS, and I think it will be sufficient. But for application SoC, it will need advanced operating system which can support application development. And those two SoC will be connected by using Ethernet protocol. Why? Because I think Ethernet protocol is sufficient to connect and communicate those two system on chip into a single H-MSoC. And we can see that for physical SoC, the focus is IP cores development and SoC configuration, and we can do monitoring also for data processing. For application SoC, the focus will be given to application development, and if we want to configure the SoC, so it can be done too, but maybe it will be not a priority here. And we can monitor and give interactive commands by using user interface. In order to achieve this architecture, we need to do a specific we need to specify the specification of H-MSoC itself, and it has to be broken down into two parts: physical SoC specification and application SoC specification. And for each SoC, the design will be similar. For example, architecture design definition, communication infrastructure, hardware design, software development, and SoC architecture until it becomes embedded SoC. If the SoC are available and are ready to be integrated, then integration into H-MSoC can be done by using Ethernet protocol. And for prototyping purpose, for physical SoC, we choose Leon 3 SoC because we think Leon 3 SoC is sufficient and has such capability for high computational needs, and it will be a platform for physical SoC that we want to design. In our prototype, we tried to add two kinds of IP cores, existing IP cores and self-made IP cores, in order to show that the configurability of physical SoC is good and it's easier to be implemented and designed for developer. And for application SoC, Zing 7000 is chosen as the platform because we consider that Zing 7000 has such capabilities to support application development. And we can see this is the architecture of application SoC. There's processing system as the main system of architecture, and we don't need to touch detail in the system because the system is given from Zing 7000, but we can try to add peripheral or add application above the system. And this is the detail and whole architecture of hybrid multi-system on chip. we can see that physical SoC and application SoC are connected to each other by using Ethernet protocol, and the SoC architecture can be different and it will be individually processed what is the responsibility of each SoC. This is the snapshot of prototype, and for design verification, especially for physical SoC, we do waveform simulation, and we can see that it was a success. And for IP cores data access without interrupt, it was a success too, and this with interrupt, it was a success too. From those simulations, we can see that the system of physical SoC is ready to be integrated with application SoC. And this is the communication test for physical SoC. We did a data transfer between physical SoC and laptop, and it was a success. And for application SoC, this is the design verification. First is communication test. We did a networking test and it was a success. And an application test, and we can try to play the test because we did a video streaming to application SoC. Let's get started. Okay, this is the video streaming from laptop to application SoC in here in a Zibo board, and the result of the video streaming are sounds here and video display here, and we can see that the video display is very clear and the sound is quite good to hear. That's why it shows that application SoC is ready to be integrated with physical SoC. And this is the test setup for application SoC. And the last is the design verification for H-MSoC. We did a data transfer between physical SoC and application SoC, and it was a success too. It means that the SoC is ready and can be developed further for specific application. These are our conclusion from the research that we have done. First, hybrid multi-system on-chip architecture is proven to fulfill the research target. An SoC technology which has A. Efficient on-chip connection, B. Easy development and implementation, C. High flexibility and configurability on physical and application development, D. The development time is relatively short. Second, design methodology of H-MSoC architecture is achieved by integrating standard SoC design methodology for each SoC and followed by multi-SoC integration by using Ethernet protocol. Last, application SoC is insensitive to latency problem. That's why Ethernet protocol is sufficient to connect and integrate physical SoC and application SoC within the H-MSoC architecture. Thank you very much. That's all my presentation. If you have any question, you can send me an email and I will appreciate your reply. Thank you very much.